Okay, this video is on graphing logarithmic functions. Now when I'm graphing logarithmic functions, I always like to take the inverse of the exponential function and that gives me a guide of what to do. So if I take y equals 2 to the x, okay, simple table of values, 0, 1, 2, 3, 4, I would get 1, 2, putting the exponent of x in, 2 squared is 4, 8, 16. So that gives me an idea of the type of curve I'm going to get for my exponential functions. I have the point 0, 1, I have the point 1, 2, 2, 4, 3, 8, and so far. When doing the logarithmic function, because it's the inverse, the x's and y's simply do a switch. So what was an x and y on the first one will get swapped. So it'll be 1, 0, 2, 1, 4, 2, 8, 3, 16, 4, and so on. And as a result, the logarithmic function, and it has, this one has the asymptote on the x, here the asymptote is going to be on the y, and it will look as such. All the points are going to get swapped. And it becomes a sideways, kind of like the exponential, but it's going sideways. Let's take another example. Y equals 3 to the x. Okay, I know the exponential looks like this. 0, 1. I have the point 1, 3. I have the point 2, 9. I have the point negative 1, 1/3. Well, all the x and y points are going to get switched for the logarithmic. Okay. So you have the point 1, 0. You have the point 1/3, negative 1. You have the point 3, 1, and it gets flatter as it goes. The next point over here will be 9 on the x and 2 on the y. So I always start with the exponential and then flip the x's and y's to get the logarithmic. Same holds true with the natural numbers. Y equals e to the x. Okay, you have the point 0, 1. And then the next point is going to be on the exponential. It will be 1 in e, which is 2.71. And then you're going to have 2 and e squared. And it's going to move up like that. It'd be negative 1 and 1 over e, because it'd be e to the negative 1 and the exponent for back here. The natural logarithmic numbers or graph is going to be the same thing. It's going to be flipped. You have the point 1, 0, and then you're going to have the point e 1, and then it'd be e squared 2, and all the x's and y's are going to be swapped to get the logarithmic graph. Now, logarithmic graphs can have all the transformations just like any normal graph. You have your vertical stretch, the a value, b value would be a horizontal, and it can be a stretch or compression. Same as this would be your compressions. And then you have your horizontal shift or translation and your vertical shift or translation. Okay, so just exact same as all other functions. Okay, but once you have the original function down, you can do all your shifts afterwards. Lesson on graphing logarithmic functions. Start with the exponential, swap the x and y's, and you get the logarithmic graph. Thank you very much.